When you type a question into ChatGPT, something that feels a lot like understanding types back. It explains, it jokes, it writes working code. So it's natural to imagine that somewhere inside there's a little mind, reading your words and thinking about them. There isn't. Inside there is only this billions of numbers doing arithmetic. No words, no meaning, no one home. So how does a pile of arithmetic end up sounding like a person? Let's go inside and watch a single sentence get built, one piece at a time. Here is the one and only thing ChatGPT does. It looks at a stretch of text and it guesses what comes next, not the next sentence, just the next little piece. Given the cat sat on there, it produces a score for every possible next word it knows. Matt scores high, Moon scores low. It picks one, sticks it on the ender, and then asks the exact same question again, now with one more word of context. Predict, append, repeat. That loop running over and over is the entire show. Every essay, every poem, every line of code you've seen it produce is just this one trick, done extremely well, thousands of times in a row. So for the rest of this video, we're going to follow one single prediction all the way through the machine, and then watch the loop close. First, one technicality that genuinely matters. The model doesn't read words quite the way we do. It chops text into tokens, common chunks that are sometimes whole words and sometimes just pieces. Cat might be a single token, unbelievable might be 3. The model keeps a fixed vocabulary of these chunks, tens of thousands of them, and every chunk has an ID number. So the very first thing that happens to your message is that it becomes a list of integers. From this point on, the model never sees letters again. It only sees numbers. Which forces the real question: how do you do anything meaningful with a list of integers? The trick is to turn each token into a list of numbers, a vector, that we can picture as an arrow pointing to a specific spot in space. Not flat 2D or 3D space, but a space with thousands of dimensions. We'll draw 3 and let imagination cover the rest. And the magic is entirely in where each word lands. During training, which we'll get to, the model arranges this space so that meaning turns into geometry. Words with similar meanings end up as neighbors. Dog, cat and kitten huddle together over here, car, truck and bus over there. And directions start to mean things. The step that takes you from man to woman turns out to be roughly the same step that takes you from king to queen. So king minus man plus woman drops you right next to queen. The model was never handed a dictionary. It built a map where relationships are directions and meaning is distance. One more touch, it also stamps each arrow with where it sits in the sentence, so dog bites man and man bites dog don't look identical. This map with positions attached is the raw material everything else works on. So what processes these arrows? A neural network, which is a tamer idea than its reputation suggests. Picture layers of little units. Each unit takes the numbers coming in, multiplies every one by its own weight. How much it cares about that input, adds them up, and passes the total through a simple bend. Stack the units into layers, and numbers flow in one side and out the other, getting reshaped at every step. Strip away the picture, and all of that is just multiplying lists of numbers by grids of numbers, over and over. Here's the part that matters most, those weights, the millions, and in big models hundreds of billions of little numbers that decide how everything mixes, are the entire brain. Set them randomly and you get gibberish. Set them just right and you get ChatGPT. So the whole game reduces to, find good weights. Hold that thought, because first we need the one ingredient that makes language models special. Take the word bank. On its own, its vector is a blur. It could mean a riverside or a place that holds your money. To resolve it, the word has to look at its neighbors. And this looking around is the breakthrough that made modern AI work. It's called attention. Here's the idea. Every token sends out 2 things. First, a query like a question it's asking. What kind of context am I looking for? Second, a key, a label advertising what kind of context I can provide. The model compares every token's query against every other token's key, and when a query and a key point the same way, that's a strong match, a high score. So if bank is quietly asking, is there money around here? The word cash is waving a flag that says I'm about money, and they light up together. Those scores get squeezed into weights that add up to 1, a recipe for how much to pay attention to each word. Then each token uses that recipe to pull in a blend of information, the values from the words it's attending to. Bank drinks deeply from cash, a little from deposited, almost nothing from the, and its vector slides from blurry straight toward the money meaning. The word just gained context. Now run that many times in parallel. These are the heads. One head might track which adjective belongs to which noun. Another, the topic of the paragraph. Another, who it refers to 3 sentences back. Dozens of these little spotlights all at once, each reshaping every word's vector with a different flavor of context. And one firm rule while it's generating: a word may only look backward at text that already exists, never forward at words that haven't been written yet. That's what keeps the whole next word guessing game honest. After the words have shared context, each token's vector goes through a second stage, this time on its own. A small feed-forward network that mashes its numbers around, asks a flurry of learned questions about them, and folds in patterns the model picked up during training. If attention is where the words talk to each other, this is where the model thinks about what it now knows, and it's where an enormous amount of the model's raw knowledge is baked into the weights. Put one round of attention and one feed-forward stage together, and you've got a single block. And then you do the obvious, greedy thing, you stack it. Again and again, dozens of times in a large model. Each token's vector flows up this tower like a signal climbing floors, getting a little richer and more abstract at every level. Down at the bottom, the model is sorting out grammar and spelling. Higher up, the vectors come to stand for things like tone and intent and meaning. By the time it reaches the top floor, the vector hovering over your last word isn't really a word anymore. It's a dense summary of everything the model has worked out about what should come next. Finally, we come back out. That rich top-floor vector gets compared against every token in the vocabulary, producing a raw score for each one. A step called softmax turns those scores into clean probabilities, and look, it's the very same bar chart we started with. The model now has its answer to what comes next. Maybe 78% mat, a little floor, and a long tail of everything else. How it actually picks comes down to a single knob called temperature. Turn it down, and the model always grabs the most likely token, safe, predictable, slightly robotic. Turn it up, and it rolls the dice more freely, more surprising, more creative, occasionally completely unhinged. It commits to one token, glues it onto the end of the texter, and then the entire tower runs again, from the very beginning, to choose the word after that. Every single word you watch ChatGPT type is one more lap around this loop. Which leaves the biggest question of all: who set those hundreds of billions of weights? Nobody, not by hand. They begin as pure random noise, and the model is taught by playing an absurdly long game of fill-in-the-blank. You take a real passage written by a human from books, articles, code, the open web, and you hide what comes next. The model guesses. At first it's hopeless. So you measure exactly how wrong the guess was, that number is the loss, and then comes the clever part. You can calculate, for every single weight in the network, which direction to nudge it to make the guess just slightly less wrong. Push them all a hair that way. That's it, now do it again with the next passage. And the next. Picture a ball on a vast landscape of hills and valleys where lower ground means better predictions. Each step rolls it a little further downhill. Do this across a staggering fraction of everything humans have ever written, with a staggering amount of computing power, and the random noise slowly organizes itself into the map, the attention patterns, and the knowledge we just walked through. Nobody programmed grammar, nobody typed in the facts. They're simply what's left over when something gets extraordinarily good at guessing the next word. But there's a gap. Everything so far gives you a brilliant text completer, a thing that, handed a question, is just as likely to write 3 more questions, because that's what web pages tend to do. It isn't trying to help you. That's the difference between raw GPT and ChatGPT, and it comes from one last phase of polishing. First, humans write piles of example conversations, good questions paired with the kind of helpful, honest answers we'd actually want, and the model is fine-tuned to imitate them. Then comes the part that really shapes its personality. The model writes several possible replies, and people rank them from best to worst. Those rankings train a second little model, a stand-in for human taste that can score any answer at all. And then the main model is nudged over and over to produce answers that score higher, more helpful, more truthful, less likely to say something harmful. This is reinforcement learning from human feedback, and it's the reason ChatGPT feels less like autocomplete and more like talking to someone who's genuinely trying to help. So step back and look at the whole machine at once. Your words become tokens. Tokens become arrows in a space where meaning is geometry. Attention lets those arrows share context until each one carries the gist of the entire sentence. A tall stack of layers refines that meaning floor by floor. The top is turned back into a probability over every possible next word. One is chosen, and the loop turns again. All of it powered by a sea of numbers that were never told what language even is. They were only ever pushed, trillions of tiny times, to guess a little better. There's no understanding hiding in there in the way we usually mean it, no little person reading your words. And yet, out of nothing but next word prediction, at a scale almost impossible to picture, something genuinely useful emerges, something that can teach and draft and argue and explain. Whether that deserves to be called understanding is a question this video can't settle for you. But at least now, when the cursor blinks and the words begin to appear, you know exactly what's happening on the other side of the glass. It's guessing the next word. It's just gotten very, very good at it.